Hello, everybody. Welcome to section 7.3a. We'll be having an A and a B. Part A, we're just going to talk about rational exponents. And then part B, we'll be doing some solving equations. So I really want you to understand what you're doing before we start trying to solve things. So our objective is to rewrite, evaluate problems with rational exponents. So first of all, you need to know what a rational exponent is. It's an exponent that is a fraction. So rational exponent means you've got, like, say, a 100 to the 1/2 power. Or maybe an x to the 5/2 power. Those are rational exponents. So you've got your fraction as an exponent, which seems unusual, but there's some rules and some tricks that we can use in order to actually figure things out. There is a legitimate answer for 100 to the 1/2 power. So let's talk about what that is and how that answer happens. So our table, like, we've got a concept, symbols, and then the example. I'll probably do the symbols first, and then we can do examples. So the concept is if you've got b to the 1/2, any number to the 1/2 power, the fraction exponent has to be 1/2. So that's our first thing to talk about, 1/2 power. So what that means is anything to the 1/2 power is really the square root of that base. Notice the base b stayed the same. The thing that changed was the 1/2 power turned into a square root sign. That's also called a radical. I'm going to talk about it as a radical or a root or a square root. So what that's saying is, let's talk about that 100 example that I gave. So 100 to the 1/2 power really means, if we're using the symbols over here as our guide, really means the square root of 100. Well, what that is asking us is what times itself, repeat multiplication, we've been saying that for 2 sections now, what times itself will give you 100? Hopefully everybody knows that's 10. Don't tell me it's 50, because that would be repeat addition. 10 times 10 is 100, or 10 to the 2nd power. So we're going to be talking about these exponents, we're going to be talking about the radicals, and we're going to be talking about that repeat multiplication. Or if we had, say, the square root of 15, which if we checked it in the calculator, would be an irrational number, so we're not going to do anything. But if I asked you to, you could write that as 15 to the 1/2 power. So square root of 15 is the same as 15 to the 1/2 power. The nth root. So nth root means that we are taking, you know how this square root of 100 is really a square root? There's kind of a little default 2 in there, square root of 100. That means what times itself, 2 of the numbers, or 10 to the 2nd power, would give you 100. Well, nth root says if you've got a to the n power is equal to b, then the nth root of that b has to be a. A bit difficult to wrap your mind around, right? So let's do that with numbers. So if I said that 3 squared equals 9, that means, I'm going to just use this little double arrow here, that means that the square root of 9 with my little default 2 in there equals 3. We all know the square root of 9 is 3. That's one of those ones we know. But let's do an example with another exponent. 4 to the 3rd power. So in other words, repeat multiplication, right? 4 times 4 times 4. Make sure you multiply, not add. If I'm doing my multiplication right, I'm pretty sure that's 64. So 4 to the 3rd power is 64, which means, if we're looking at the symbols over here, that means that the cubed root, or 3rd root of 64, must be 4. In other words, what times itself 3 times will give you 64? That's going to be a 4. So you can go to your calculator, you can do some trial and error. What times what gives you 64? Or you could use that cubed root button, and we'll talk about that in class so that you know how to use that, as well as the squaring the exponent button. We'll make sure you know how to do 4 to the third power without typing in 4 times 4 times 4. It's fine when it's only 3 fours, but if we're talking about something to the 6th power, it starts to get a bit tiresome. So, all right, our next one, rational exponent, is b to the 1 over something power. Instead of 1 over 2, 1/2 power, we could have 1 over something. B to the 1 over n power is really the nth root of b. So, for example, if I said 8 to the 1/3 power, that's tricky, it's difficult, it's kind of hard to wrap your brain around. What we're really saying is the third root of 8. Or if we're thinking repeat multiplication, what times itself 3 times altogether, what to the third power, will give you 8. I'm going to say over here on the side, the answer is 2. Let me know if you get that. What times itself 3 times will give you an 8. What times what equals 8? Or if I said 32 to the 1/5 power, let's write that as a radical. So this is a rational expression, 32 to the 1/5 power. A radical expression is using the square root sign or the cubed root sign. Or in this case, what little root do I put in here? A 5, right? So that denominator is going to go. So in other words, this is where it starts to get a bit cumbersome. What times itself 5 times, repeat multiplication, will give you 32? Well, we could do the 5th root of 32 on the calculator, or you could do some trial and error and start plugging in numbers. You know, 4 times 4 times 4 times 4 times 4 times 4. Will that give you 32? I'm interested to see if you get 2 for your answer. In other words, 2 to the 5th power, you could try that out too. You could start doing, instead of doing repeat multiplication, you could try 2 to the 5th power, is that 32? 3 to the 5th power, is that 32? So our last concept kind of takes that last one, b to the 1 over n, one step further. So we had b to the 1 over n power is the nth root of b. Well, this time we've got this b to the m over n. We've got one extra thing. So we've got the nth root of b, but then this numerator becomes the exponent on that b. The n, here's how I always think of it. I'm a visual person. I always think of it as this denominator swings around and becomes that root. I don't know why I think of it that way, but it works for me. I'm going to erase that. I'll do it later as we go through examples, because I don't want you to write down crazy things. But so b to the m over n equals the nth root of b to the m power. Or you can take the whole m power out, and it's still the nth root of b. None of that has changed. Nth root of b. But the m just becomes a bigger power. So in other words, you can do the repeat multiplication b to the m power, or you can figure out what the root is first and then do the repeat multiplication. So let's do this example. I've got an 8 to the 2/3 power. So first things first, let's write that as a radical expression. So remember, here's my little aid. The 3 swings around, and then the 8 to the 2nd power stays. Well, you can keep that 2nd power on the 8 if you want, or you could do the 3rd root of 8 first and then square the answer since it's a 2. Since above here in the previous example, we found out that the cubed root of 8 was 2, or 2 times 2 times 2 is 8. We could say, all right, well, the cubed root of 8 is 2. And then I'm going to just bring that squared over, so 2 squared is 4. This is some calculator math. This is some understanding what an exponent does and understanding what a root is. It's all about repeat multiplication. So let's do a 36 to the 3/2 power. 36 to the 3 over 2. So most difficult part is getting this guy into a radical. So again, I've got myself the 2, the denominator swings around, and then the numerator, the 3, stays on there. I'm going to put parentheses like I did on the last one because I think this is an easy problem. Because what that's saying then is, what's the square root of 36? Take that answer and cube it. Well, what is the square root of 36? Everybody knows that's 6, right? What times itself will give you 36? 6 to the 3rd power is a little bit more work, and I think that's 216. You can double check me and tell me if I'm wrong. There's nothing worse than having the teacher be wrong. So you can do 36 to the 3rd power, but I just thought, holy man, those answers are going to get really big if I try to do that. So there's our 4 rules. They're really not even shortcuts. They're just rules at this point. So the first set of practice problems, it says to write each expression in radical form or to put it in exponential or rational form. So if I've got 36 to the 1/2, I just want to first of all turn that into a square root. So the bottom, and it works for everything. 1/2 power is easy to remember, but remember the denominator comes around. The numerator stays as a power. Well, it's just a 1, so it can stay that. So square root of 36, if we're going to evaluate, is just 6. But this is really the part I want to make sure you understand what you're doing. Number 2 and 3, please notice the difference between those. 3, I've got parentheses, 2, I do not. This 1/2 power for number 2 is really like 5 times x to the 1/2 power. So when I swing the exponent around, it's only going on the x. So I'm going to have a square root of x, and that, oh, let me write that the right way. I'm going to have a square root of x, and the 5 didn't do anything. You do not have to write the 2 for square root. We know that's like the default setting. So really, I would write it as 5 times the square root of x. But if you had the 2 there, it would not be wrong. Number 3, though, the 1/2 is on everything, right, with those exponents, with those parentheses. So I'm going to take this and swing it all the way to the beginning and make that a square root of 19ab. I'm going to stop writing the square root. I don't have to write a 2 there unless you want to, but 2 is really like, you know. So notice the difference between 2 and 3. It's kind of a tricky problem. Number 4, it gives us the radical, so let's put it in exponential form. So 12 to the, or square root of 12 is the same as 12 to what power? 1/2. We know that's a little squared right there. Square root of 18b. Notice the whole 18b is underneath that square root sign. So it's going to be 18b. You have to have parentheses to the 1/2. Otherwise, it's going to be like problem 2 right above, where the 1/2 is only on the b and not on the 18. And number 6, I've got a little 3 in here. I wanted to make sure we mentioned that. So this one, I'm just going to do my 37h, because that's the whole thing underneath the square root. If there's no exponent, it's a 1/3. So this index, it's called, becomes the denominator. 37h all to the 1/3 power. Kind of mind-boggling to go between fraction exponents and radicals. These ones have kind of a 2-part thing. So it says to convert between radical and rational exponents and then evaluate. So we do want to understand that there's an answer, and I've been trying to do that as we go along. So first of all, I've got a radical, so I want to turn this into a rational exponent or a fraction exponent. If you want to go to your calculator right away and do the cubed root of 125, please make sure you talk to me if you don't know how to do that. We can do that, but really what that means is something to the 3rd power equals 125. You could do some trial and error. You could do a cubed root of 125 on your calculator. Or if we're going to write this as a fraction exponent, that's going to be 125 to the 1/3 power, because that becomes the denominator. If there isn't a power, it stays a 1, so that's why it's 1 over 3. The answer to this, the cubed root of 125, or 125 to the 1/3 power, is 5. Ignore that phone ringing. Number 8, we've got a cubed root of 64. So again, you could do your calculator right now and get the answer. Let's turn it into a rational exponent. So 64 to the 1/3 power. You could go to your calculator and put that in as 64 to the 1/3. Be careful about 1/3. It's a repeating decimal, so you got to put it in as a fraction. But really what that means is something to the 3rd power equals 64. If you do some math, if you do your cubed root button, if you do your 64 to the 1/3, you end up with an answer of 4. I'm going to skip number 9. Again, that would be a good problem for you to go back. Let's talk about some with some crazier things. Actually, let's go to number 11. Well, let's do 10. So the 4th root of 2401, that means something to the 4th power equals 2,401. That's a tricky one. You might have to do some trial error. Please ask about your 4th root button. Or you could do a 2,401 to the power of, this becomes the denominator. If there's no exponent, it's a 1. So 2,401 to the 1/4 power. Number 11, I'm giving you a 1. Oh, and we should do the answer, right? 2,401 to the 4th power, or the 4th root, is 7. Test on your calculator. 7 times 7 times 7 times 7. Repeat multiplication is that 2401. 256 to the 1/4 power, if we're going to write that as a radical, I know 256 is my base. I know that this guy swings around and becomes the 4th root of 256 to the 1st power. And then I can go to my calculator again. So in other words, what times itself 4 times gives you 256. I believe that's going to be a 4. Or 4 to the 4th power. I'm going to skip number 12. It's a lot like number 11 because I want to talk about a problem like 13. 64 to the 2/3 power. So I'm going to do, and you could go to your calculator and you could type in 64 to the 2/3 power. It is a repeating decimal, so be careful. Or we could do this guy. Let's turn this into a radical. So the 3 swings around, 3rd root of 64 squared. So we can do some math on your calculator and figure out what is the cubed root of 64 and go from there. So go to your calculator. Let's do the next one. I want to make sure we don't take all day. We're going to do the same thing. Let's turn that. So a cubed root of 27. And remember, you're squared, just like this one, you could do first, or you could square the 27 and then take the cubed root of it. Well, cubed root of 27 is 3 to the 2nd power is 9. On that last problem, did everybody figure out the cubed root of 64 was 4? By the way, I shouldn't have just passed by it. Don't forget to square after you get that answer. I think it's easier to square after. Last one, 9 to the 5/2. This is a good one. So this 2 comes around and becomes a 2nd root of 9. I like to put the 5 on the outside. I like to find the smaller answer first, and then I can do the 5th power. What is the square root of 9? 3 to the 5th, that's a nice big number, but it's not impossible. Remember, it's repeat multiplication. So 3 multiplied 5 times, and I'm going to end up with a 243 for that one. So there's really 2 things to this back side of problems. One is knowing how to turn them back and forth. I want to do that. And then one is knowing how to evaluate. So we'll make sure that everybody understands how to use your calculator. You need a calculator, not a phone. You need a calculator that's got that where we can do cubed roots or square things or fifth power things or whatever we need to do. So today's lesson summary. What's the trickiest thing about these exponents, these rational fraction exponents? What do you see that you might have difficulty, or what are you having a hard time kind of wrapping your brain around? That way we can talk about those. And your practice problem? Don't even evaluate. I don't think it comes out to a whole number. But if I give you the 7th root of 2,501 to the 5th power, just write that as a rational expression. In other words, I want it to be a base to a power, no square root signs. That's it for today. Have a great day.